All right, in section 7, we're going to be solving inequalities. So we're going to talk about compound inequalities and linear inequalities with this. We're also going to be doing some graphing on a number line, and then also interval notation. So just to let you guys see the first type, oops, x. Okay. So for that particular problem, what we want to do here is we want to get x by itself. So very similar to solving a linear equation where I want all the x's to one side and anything that's not an x to the other. So what I'm going to do is I'm going to subtract 9x to both sides. I usually like having my x to the left and my number to the right. That's a personal preference. It really doesn't matter. Also, a lot of times I like to just do the x as positive. But it's all about what your style is and what you prefer. So I subtracted 9x over, and the reason why I did it that way this time was because when I divide by a -6, whenever you're adding or whenever you're multiplying or dividing on an inequality by a negative number, you must flip your symbol. Symbol meaning the inequality symbol. That will flip over to a greater than, and then if I reduce my fraction, I get -2/3. So, in solving an inequality, again, when you're doing this, you want to make sure that whenever you multiply or divide by a negative number, you have to flip that symbol. So if you don't flip it, it's going to be wrong. Alright, so now, as far as graphing that, when you want to graph -2/3, you go in between -1 and 0. And you're going to put an open circle on that. The reason why you're going to put an open circle on that is because it's not equal to. It's like a big giant hole that you can come right up to but never actually go into, because otherwise you'll fall. Now, when it says greater than, or basically what happens for me is if Pac-Man is going to eat the letter, we're going to shade to the right. If Pac-Man is going to eat the number, you shade to the left. So since he's eating the letter, we're shading to the right. And our final answer looks like that as far as graphing. The reason why I say it the other way that I said it was because if it would have been like this, what some people do is they shade towards the way the arrow is pointing, and that's not the correct way. If Pac-Man is going to eat the letter, you shade to the right. Now, interval notation. Interval notation is a notation that we use in order to tell us where the number starts to where it stops at. We can go from -infinity to positive infinity, -infinity being all the way to the left, positive infinity being all the way to the right. So for this particular case, it started at -2/3, but it was not included. So not included, we use a parenthesis. If it's included, we use a bracket. So that means if it would have been underlined, or if it would have said equal to. Now, where does it stop at? It stops at infinity because it goes on forever. Now, it doesn't actually stop at infinity. We just know that it goes on forever. And that's what it ends up going to look like. So that's solving a linear equality. Next one I'm going to have for you is going to be a compound inequality. And the words compound are just like compound words when it comes to English and whatnot. We're just combining two things together to make one. You can do it one of two ways, where you can cover up one side, do it, and then go back and cover up the other side and do it separately, or do it at the same time. Goal is get x by itself in the middle. So I'm going to add 2 first. That gives me 6. 3x is now in the middle. 15. How do I get rid of the 3? Divide. 6 divided by 3 is 2. And 5. Now, again, I did not flip my symbols on this one because of the fact that I did not divide by a negative. Had I divided by a negative, then I would have flipped the symbol. So if I'm not dividing by a negative, do not flip the symbol. Now, as far as graphing this on a number line go, my students, I usually require them to go one number higher, one number lower than the numbers that they need. They need 5 and they need 2. So I want them to put a 6 and I want them to put a 4. I want them to put a 3 and I want them to put a 1. Just so that they know which way is which. Now on the 2, I'm going to put a closed circle. Now why am I putting closed? Because it said equal to. On the 5, I'm going to put an open circle. Why an open circle? Because it didn't say equal to. I over-exaggerate my circles just like this, and I do this when I'm doing my own work on it because I want the reader to know this is where the dot is. You know, a lot of times I have students that put small circles, then it's really hard to determine whether or not it's supposed to be open or closed. I've seen some books put it where they put the bracket and parenthesis from interval notation right on the number line also, which is perfectly fine. Now as far as shading it goes, we want to shade everything that is greater than 2 but less than 5, which means everything in between it. Then as far as interval notating it goes, the furthest left point that we had to deal with was 2, and I put a bracket on the 2 because it was a included, and I stop it at the 5 in a parenthesis because the 5 is not included. It did not have equal to. So just so that you guys are aware of it, do not put the numbers in between all those things, because if you do, the numbers in between, you could be writing every number down there for the rest of your life. Even the numbers between 2 and 3, for instance, are too many to list. So make sure that you it's a starting to stopping is what the thing is. So just so that you are aware of it, that is my interval notation. That's a compound equality or inequality. Just so that we are aware of it, that's what we have for that one. Okay. Now, what if it's not linear? So what if it's something different? What if it's something like x squared is less than or equal to 5x minus 6? This is a quadratic type. Now what I do when it's a quadratic type is that I get everything to one side versus the other. So I'm going to subtract 5x over and add 6. And then from here, I'm going to factor it. Okay? It's a quadratic, and it can factor. So I'm going to factor x minus 3, x minus 2. When I multiply those, it gives me positive 6, but when I add them, it gives me negative 5. And then when I set them each equal to 0, I will get x equals 3 and x equals 2. Those are my numbers on my number line. Four, 1, and they're going to be both closed. Why are they both going to be closed? Because of the fact that it said equal to. Now, from here, a lot of times what it has is what we did is we broke it into 3 different zones. We broke it into zone 1, zone 2, and zone 3. Zone 1 is everything left of 2. Zone 2 is everything between 2 and 3. And zone 3 is everything to the right of 3. A lot of times people think it's automatically just in between them, but that's not the case. Your book gives you a chart that you can go off of in order to figure out which way is which. I've never really been a big fan of the chart, so I'm more of a fan of doing a test value. And what I mean by that is I'm going to pick a number in zone 1, like the number 1, put it in the original problem and see if it works. So 1 squared less than or equal to 5 times 1 minus 6. 1 squared is 1. 5 minus 6 is negative 1. So you ask yourself, is 1 less than or equal to negative 1? No, it's not. No shade. What's a number between 2 and 3 would be 2.5. 2.5 squared less than or equal to 5 times 2.5 minus 6. 6.25 less than or equal to 12.5 minus 6. That is true. So that means we shade in between. Don't assume that just because it shades in the middle that we don't even have to test zone 3, because that's where it gets us in trouble. So make sure you put one in there for every zone just in case. Because sometimes I've seen them where they would do 2 or do 1 or none of them. So just be very careful as far as testing all your zones. And we just saw that one didn't work. So for this particular thing, I'd have a bracket at the 2 a bracket at the 3 because they were included on both. And that's my solving an inequality that is not linear. Okay? Now, in the assignment for this section, they have a couple different ones, and they have a couple of them that actually are already, factored for you. If they give you one like x plus 2, x minus 1, x minus 3, that's already factored. So there's no sense in you guys multiplying it back out when you can just take the numbers from here and say that's -2, that's 1, and that's 3. And those are the numbers that need to belong on your number line. -2, -1, 0, 1, 2, 3, 4. Close circle, close circle, close circle. Now for this particular thing, I did not break it into 3 zones. I actually broke it into 4 zones. So I got to test the number in each one of those zones. -3 plus 2, -3 minus 1, -3 minus 3. -1, -4, -6. When I multiply all those together, that gives me -24. Is that less than or equal to 0? Yes. Now I'm going to put 0 in there. 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 3 is -3. When I multiply that together, I get 6. Is that less than or equal to 0? No. No shade. 2 plus 2. 2 minus 1. 2 minus 3. 4. 1. -1. When I multiply that together, I get -4. Is that less than or equal to 0? Yeah. 2 zones work. 4 plus 2 is 6. 4 minus 1 is 3. 4 minus 3 is 1. When I multiply those together, I get 18. Is 18 less than or equal to 0? No. So now in this case, I have 2 different parts. I have a shade to the left of -2, and I have a shade in between 1 and 3. So I got to write both parts down. Negative infinity, because it goes all the way to the left, up to -2 with a bracket. Then I use a symbol called a U. A U is short for union. That's where you have 2 or more pieces together. That's how you write it if you have more than one piece. And then 1 to 3. So I didn't actually have to factor itself. It was already done for me that way. So I just had to pull the numbers out and then test the zones. And now this interval notation here or the graph is my answer. So I've solved it that way. That's as far as what you need to do for that one. The next type that you're going to have is if you have fractions involved. And this is actually the last type that you have. When you have fractions involved, there's 2 parts to this. First of all, I'm going to pretend for a second that it's equal to 0 rather than the inequality symbol. I'm going to just pretend it's equal to 0, and I'm going to multiply by the common denominator, like we did in one of the other sections. When I do that, that cancels out, leaving me x plus 3, and when I do it here, anything times 0 is 0. So I get -3. So x equals -3. That's a number that needs to go on my number line, for sure. So -4, -3, -2. Unfortunately, that's not the only piece. Now, a lot of times what we do is we say, well, it's this, and we shade everything to the right of it, and we include everything for it, and the reason why we right of it, because it said greater than, but you would be wrong. If there is a bottom, any denominator whatsoever, you also need to put the denominator equal to 0 and solve for x, and you will have another dot at 1/2. So -1, 0, 1. You'll also have a dot, but this one has to be open. The reason why it's open is because you cannot divide by a negative number there. So if you have it as a closed circle, you'd be dividing by 0, and that's not possible. So now my zones get broken into 1, 2, and 3. So if I put -4 in there, -4 plus 3, 2 times -4 minus 1, -1 over -9, which is positive 1/9, is greater than 0. If I put 0 in there, 0 plus 3, 2 times 0 minus 1. 3 over negative 1. That's not true. But if I put 1 in there, 1 plus 3 is 4. 2 times 1 minus 1. That is true. So what would have happened is, if you did not put the bottom equal to 0, you would have got the stuff to the left, but you would not have got the piece to the right. So for my final answer, I have negative infinity to negative 3 with a bracket, then a union, parenthesis, 1/2 to infinity. It's important that you put any bottom piece also equal to 0. If it has more than one fraction, then you'll have more than one dot. Okay, so be careful with that when you have fractions involved. If there's more than one fraction, then you have more than one dot stemming from the bottom. Okay, so with that, then that's as far as section 7 goes. Pretty short section in solving equalities. So see you later.